Okay, good morning, everyone. In today's class, we make some more advanced machine learning experiment within PySpark environment. So far, you have seen that the necessity of Hadoop and the advantages that it brings for working the large data sets. We have some map-reduce experiment using Hadoop core, and we have seen that for further advanced analytics, especially machine learning, Hadoop core may not be enough and not that much efficient. So we focus on other tools such as Peak and Spark. So in Spark, we started to do some machine learning projects, and basically we had some basic experiment how to use machine learning algorithm in a simple data mining projects. From now, our focus would be mostly on the Spark environment. We also checked some standards for doing data mining projects. So one of the most famous one is CRISP-DM. In CRISP-DM, you have you basically need to know the background of your data, understand the data, each variables. You do some data preparation, basic training model, and the evaluation part. You look at the performance of your algorithm. If they are not that much great, maybe you need to go back, change some parts, maybe use different algorithm, different data preparation steps. And then again, you go ahead and get to that evaluation part and see if you have a good model or not. Having said that, you will see an assignment that I ask you to provide your data source and group members. So basically, you already know from the first class of this semester that what would be the final project. It's a machine learning project, but you need to do it in a Spark environment through a team. So you have a few days to give me those information. What is your data source, the topic, and the team members. So, but how to do coding in the modern era? Basically, you need to know the basics, especially speaks of PySpark or Python. But usually, you don't need to invent the wheel. If you forgot the basics of Python, how to define function, how to do queries, maybe you can go back to some basic courses either through DataCamp or Coursera. But no worries, either in this course or future, usually there is some basic notebooks that you build on top of them and make them more advanced and a better case for your specific need. So even like for your project, you can even use the Jupyter notebooks that I'm sharing in this course, but probably for your project, you need to change them a lot. So you don't need to start from scratch for your project. You can use the notebooks that I provided, but change it in the way that is the better case for your project. For the basics, you need to do a lot of practice. So the best way is just do more and more coding. So if you do them, you don't need to memorize how to define a function. You already can understand it. It's just stick in your mind automatically. So anyway, for this project and most likely in future, you don't have to do everything by yourself. Usually there is a team of programmers or analysts that work on a certain part of a project, and they share codes with each other. So maybe two of you work on data preparation, two of you work in basically data collection or other steps. And in the industry-style projects, you need to do a lot of collaborations and understand how to do that. So there is some traditional way of that, like for example, sharing code over a simple cloud drive, like OneDrive, Google Drive, or Dropbox even. But in the modern projects, people use more advanced tools such as GitHub. this is like for social coding. So basically, there's a group of collaborators that make an account for their project, and they connect to that account and just share all the codes in one location. It brings so much more advantages than the traditional way of sharing codes and doing collaborations. For example, you have the version of the codes that you made, and if just in the case you have issues, you can go back to the previous versions and see, look at all of the steps that you did for a project. For your class project, you can do it as a bonus. So I don't have time to teach you how to work in the GitHub, but learning GitHub is not a difficult task. There's so many easy YouTube videos that you can just see how people do. It's a good practice to learn it now, because in the future, most likely you need to know how to work with that. So if you already know how to work in a GitHub environment, it makes your life much more easier later. So any questions so far? Oh, okay. Okay, let's go more in depth.
So I have a question.
The steps. Okay, go ahead.
My question is, so if we do the project in the Spark Hadoop environment, do we need to do in the Databricks or in the PuTTY?
Either way, I mean, I just need to, I just get your code and I should be able to run your code. So even AWS or Google Cloud, anywhere you can do that, but your code should be runnable. I should be able to run it and get the results. So
okay,
any platform, you're more welcome to do it in any platform. But by end of this week, you should provide your group names and the project title and so on. And again, it's a good practice to do it over GitHub. So it brings a good experiment. But since it's something extra, and it's for high-end students. So if you are not interested to do that, that's totally fine too. So for missing values, okay. Any questions?
Okay. No, I'm good.
So,
thanks.
Okay. So when there is so many reasons you might get some missing values in your data. It's a very common thing that you face some missings. They could be completely at random. There is no justification, just randomly happens. It could be typos that somebody did, and then later if there is a typo, maybe they just delete the data, or any random reasons. But sometimes they are not completely at random. It happens. For example, might be do a survey and female respondents, they are not interested to provide their age or other personal information. It's not for every female respondent, but might happen. So it's not completely at random, or missing not at random at all. So especially in the healthcare, maybe the organization that collect the data, after a while, they stop collecting the data, or they start to collect the new data. Let's say from 2002, suddenly they want to do blood pressure and attach it to the patient data, or hormone tests after 2010. So for any observation before 2010, the data, there's no hormone test information. So there is an actual reason why you have missing values. For those cases, we say they are not at random. For the observations that or cells that are missing at random or not at random, usually we just delete them. For example, for patients, let's say they stopped to test hormone tests after 2010. So we just disregard that variable. So we just drop that column. When they are completely at random, we do imputation. And there's several algorithms to do imputation. It could be predictive, so use some algorithm to predict the empty cells, or you can just use simple statistical imputations. Here, in this course, you're facing the big data. Predictive imputation takes a lot of resource and might be very time-consuming for a large data set. So simple statistical imputation should be fine. Sometimes there is too many cells in empty cells in each column. Let's say 95% of a column is empty, or 98% of an observation or row is empty. Those cases that too many is empty, you drop that rows or columns. Otherwise, you keep everything. Because by dropping observations or columns, most likely columns, you might face some bias. You remember we talked about credit card applications. So if let's say for female respondent or applicant, they drop so many columns, maybe your model won't be that much great in predicting the female credit card. So anyway, for avoiding bias, whenever we is missing value as a completely and they're completely at random, we do imputation. Another thing that probably we don't have time to talk about this class, but next class we talk about that is feature selection. There is two major reasons for doing feature selection. First of all, avoid stacking the local minimum, local maximum. Let's say I want to minimize error, and I'm talking about the under hood of the algorithms. This is out of context for this class, but let's say I want to minimize error. Here, I have a local minimum on the right side, but the global minimum in the left side. So let's say you do some parameter change. So your error gets a smaller, or if you go from here, your error, you are minimizing up to this point. Or if you start from here, you get to the minimum here. But if you go further, I'm just saying an example. This is something under hood of the algorithms.
So what's the meaning of this curve?
I'm just talking about what does a local minimum and global minimum means. But these are like, it could be anything in any algorithm. So let's say I'm talking about minimizing error, and I'm moving from right to left. So from here, I'm minimizing, but it's negative. It's not a good way of talking about error. We don't have a.
It's like the left figure. It's like the difference between that curve, the train curve, and the test curve, right? The real curve and the.
No, actually, the local and global minimum basically is talking about how each model trains.
What I mean is. This curve is this curve.
No, there are two different things.
It's two different.
Yeah, the left side is for overfitting.
So I know it's overfitting.
Yes, but the right side is not for overfitting. So anyway, I know it's kind of might be fuzzy because I need to go inside the algorithm, but I'm just saying that. Let's say when you have too many variables. Instead of saying stacking the local minimum, local maximum, it doesn't train well. Maybe it's a better term because you don't know the background of the models. Yeah. So, but the second reason for avoiding overfitting. So look at the green line. The green line classifies the red balls and blue balls correctly. Everything is in the right side is blue and left of the green line is red. But it's fitted very well for train set. It may not be, you may not be able to generalize it for a test set. It may not be applicable. So when you do, in such a case, maybe your train accuracy is 90%, but for the test accuracy, maybe 70%. So there's a huge differences. But the black line is when you have a smaller number of variables. So you might, in the train set, you might have more error, but your prediction accuracy in the test set is not too bad. You can generalize it in the test set. Sorry, for local global maximum, this is a very mathematical thing under hood of the algorithm, but you can just assume they don't train well. Okay, so for today's class, we have a more complex machine learning project using PySpark. So go to your Moodle, down from your week 9, download Titanic2.csv and the Jupyter notebook and import them into Databricks. For importing the Jupyter notebook, let me just show it again. So you go home, you go to the ID, click here, select import. So again, in Databricks, click on home, ID, import. And just browse to your Jupyter notebook and bring it to here. But also run a cluster and also bring the Titanic2.csv. So I already talked about it quite a bit. So I give you 5 minutes to bring your Jupyter notebook and also bring the Titanic2.csv. It might take like 3-4 minutes to run the cluster. So
Got to the file is in week 9 or week 8.
pardon me?
I mean, there are two Titanic files.
Yeah, just no. In your model, there's just one Titanic file. Okay, hopefully by now you'll be able to run your cluster and import Jupyter Notebook and also the Titanic dataset. So again, the similar steps are very similar. We import a Spark session. We make an app, and with the Spark read.csv, we import our file using the default schema or the schema that PySpark could guess. Let's look at the schema. And compare to data dictionary. So passenger ID is integer. Is it right or not? So passenger ID imported as an integer because I printed the schema. So it's what do you
It should be string. It should be string, I think.
Yeah, passenger ID has numbers, but the numbers doesn't mean anything. They're just an ID. So since it's ID, should be a string. Survive is integer. Should it be integer or not?
Yeah.
Actually, I
No,
think
it
it's
doesn't mean one. Yeah,
be
they are
string.
just means that. Yeah, I mean survive are 0 and 1, but 0 means die, 1 means survive, or otherwise. Yeah, 0 means didn't survive, 1 means they survive. So these are labels of categories. One of your friends should mute. He's a speaker, otherwise it brings a lot of noise. So yes, survived should be categories. So here we should see the string, but it's an integer. But interestingly, when you want to import your data into the machine learning algorithms over PySpark, all of the values should be numerical. So although survive should be string, but later all of the strings should be converted to the numerical equivalent, and so we can just leave as it is. You can leave it. So name should be a string, sex a string, age double, which is numerical values, number of sibling, parent, all of them numerical. Ticket a string, fare double because it's a numerical value. Cabin is a string, is a cabin number, so it's just a label, so that's fine. And also embark is a port that they are embarked, so that should be string too. On top of that, we don't work with the labels and use it in prediction. We just want to use the columns or values that make sense, which are survive, P class, sex, age, sibling, parch, freight, and embark. I don't use passenger ID and I don't use cabin or cabin number or cabin ID. So I already exclude these two. So having said that, by using a struct type, you can make a schema that you are interested or should be. So in this schema, I said passenger ID should be a string, cabin should be a string, embark should be a string, sex and name should be a string, P class should be a string, and the remaining are numerical values. Also, name is a identifier of person, so we don't work with the name later too. So with data.collect, we get the value of the data that we imported. We just said create a Spark data frame out of that using the schema that we defined up here. Now, I converted to the PySpark data frame with the schema or column types that I want. Let's print a schema here. And these are the true schemas. Let's see if I already run here. Yes. So with dot select, method, I'm selecting the columns that I want. For example, I exclude name column, ID columns. So I'm focusing on those columns. Then I make a loop over column names. And whenever there is a null value there, I count the number of cells that they are null. Let's look at them. So these are distribution of or frequency of null cells or empty cells for each column. Let's see how, with dot count, you can understand how many observations you have in each column. With dot df dot columns, it brings the columns or variables that you have that remain in the data frame. With the len function, you can count how many are those columns. So let's see how many columns and rows we have. So we have 891 columns, sorry, rows or observation, and 8 columns or variables. So out of 891 rows, these are my empty or null cells. So for age, do you think it's good to drop it or impute it? Or how I impute it? Is it?
I like to use model or median to import.
I think like 8 is a very big number, 177. That's a big number, so I think we should fill it up with the average.
Yeah, 177 is number of empty cells, but yeah, you can impute either with the median,
Yeah,
I have a standard.
median or
mean, yeah.
I have standard. If the scenario is more than 20%.
If it's too low, if it's too empty, like 95% empty, just drop it. But 177 might be around 25%. So you shouldn't drop that. Otherwise, you are prone to have bias in your prediction. So what about, what else? Embark, which means the port that the passenger get to the ship. Which kind of imputation should I use? Mode, yes. For categorical empty cells, we use mode. And again, there's other methods, not just mean, median, and mode. You can even predict those empty cells. But when you work with the very large data, it's not that much. It doesn't make sense that much to do computational extensive algorithm. So statistical imputation is enough. What about survive? Which kind of imputation you recommend? Yes, you are right. For survive, this is my dependent variable. I shouldn't impute. I just drop it. Very good. With the describe method, you can see a statistical description of each numerical variable. So here I just select the numerical columns. With describe method, I'm getting a statistical summary of them, and dot show, I'm just showing those descriptive statistics. Let's look at them. So for example, for age, number of sibling, parent, and the fair, you see how many observations you have, mean, standard deviation, mean, and max. I have a question. Do you see any weird values over there? For example, do you think having the minimum age of 0.42, does it make sense or not? Yeah, why? Yeah, newborn babies, yeah. They could be less than 1 year.
Yeah.
So what about fail? The minimum is 0. Does it make sense or not? Fail, yeah, means, or maybe illegal passengers.
Maybe don't need to
Yeah,
Maybe don't need to
but they don't have ticket too.
Yes.
So again, so here, when you do descriptive statistics, if you see weird values, let's say age of negative doesn't make sense, right? So whenever you see weird values, maybe there's a typo. You just need just make them null and use it for imputation later. So here, we can find a reason for why we have such values. If you don't have any reason and for you some values doesn't make sense, it's better to just delete those cells or just put null and you use them for imputation later. Here, we don't need to convert any of cells because all of them, we can't find a story for any of them, so we can keep them for later. Okay, from sklearn, I'm importing simple imputer for imputing. And since input of simple imputer is a Pandas data frame, yeah, so I need to convert my data frame into Pandas data frame to be able to use simple imputer. So for using simple imputer, I need to do conversion, format conversion. So there's no mathematics behind of that, because the only reason we do conversion because some function or just can get inputs from certain formats. For input of simple imputer is Pandas, so we need to convert to Pandas. Right now, our data frame is in a Spark format, PySpark format. So with two Pandas method, I convert df to Pandas, and I'm making a deep copy of that. I explain later what this deep copy means. Basically, when I use copy, or I with true as a deep parameter, or just leave it as empty. So I don't have to define deep equal true. In those cases, I'm making independent copy. If I don't use copy method, or instead of true, I put false, I don't make an independent copy. I just make it two variables with the same data. Let me explain here. Okay, this is my data. This is the actual data. And this data could have different names, like df, data, maybe data frame. Okay. So when you do this, when you say, let's say df2 equal to df, or you say df2 equal df dot copy deep equal false. In either of these two, you just make a new variable of df2. So whenever you do any changes on df using df to name, all of the df data and data frame would change. But if you do this, if you make df3 equal df, you make a new copy, actual copy, with the name of df3. So now, if I do any changes on df3, or any change on here, it doesn't change on the left side. I just change the right side. Just the reason we use that method. Sometimes it's a good approach, sometimes it's not. It really depends on the application, your application. Let's say if your data is too large, maybe you're not interested to have an actual copy. Maybe you just want to have different names for that copy. Sometimes the size of your data is not too much important. You want to have multiple copies. So you use deep copy. So I make an independent or deep copy of my data DF and call it miswork. And also I'm creating a simple imputer object with median as an imputation. And as you see, miswork is a deep copy of my data, and I'm calling ilike method, which you might remember in the Python course. So we can, with ilike, you can identify which columns and rows you're working with. So if I go back here, column 0 is survive, 1 is p class, 2 is 6, 3 is age. I'm just saying that ilike 3 to 4, which 4 is not included. So what I'm doing, instead of column ilike of 3 to 4, I'm doing median imputation under. So what it does, it takes that column, and for any empty cells, it does imputation. Let's look at what happened, have an experiment of deep copy. Here, I'm converting the data to a sample, a Pandas data frame, and I don't use a deep copy method. I'm just saying that sample copy equals sample. With this, I don't make an independent copy of my data. I just make a sample copy as a new name for that actual data. I'm just saying that change column 5 of that data to 1, and let's look at the sample copy. Column 0, 1, 2, 3, 4, 5. Age, all of them is 1. So I just work on the sample copy, not on the sample, right? But let's what happened to the sample. Also, sample is changed to the column of age in the sample, also changed to 1. Because sample and sample copy are not independent. They're just two names for one data. Again, it depends. In some cases, you want to make an extra copy. In some cases, you just want to make a new variable for the same data. Any questions so far? For the people, I give you like 1 or 2 minutes to play with the codes, and if you have questions, I try to help you. Otherwise, I go to the next step. So you have just 1 or 2 minutes to work with your codes. Yes?
We've already changed the sample copy, but why we also changed the sample?
Because sample copy and sample are just two names of one data.
It's points to one location in the computer. You have to add the copy and the copy to the other location.
So again, let me talk over whiteboard. Okay, your friend asking about, so this is my data. So we have age column, P class, and other columns. The address or the, you can, even address is a good term for that. So the address or the name is sample. If I said sample copy equals sample, I don't actually make a copy. I just copy the address or the name. So again, sample copy. So again, both of them are refers to one data. So when I change age column in sample copy, so for example, sample copy, let's say age equal 1, it goes to this name, find the address of your file, comes to the age and change it to 1. Again, when I call sample, it gets to the same data. Again, all of the age columns are 1. I hope it makes sense. Okay, so next part is just doing mode. I'm doing mode for the embarked variable because that one is a categorical variable. Also for survive, I'm using drop NA method to drop any observation that the survived value is null because I don't want to do imputation for dependent variable. Look at here, I use drop NA method. This is a Pandas method. You might remember in the previous class, for dropping observations, I used this method. I used NA drop. That is a PySpark method. But here, since I converted my data frame into Pandas, yeah, here you can use a Pandas method. Might be a little challenging, but it brings a more flexibility because here, for imputation, it's much easier to do in Pandas. So I convert everything to Pandas, use Pandas method and functions. Then for the remaining, I again converted back to the PySpark format. With the spark.create data frame, I convert my Pandas data frame, which I did imputation, to the Spark data frame. Now, I'm making a loop over the columns of data, PySpark data frame, and I'm counting how many nulls I have. It should be 0 now because I did imputation and drop the null observations. So yeah, it gives me some error here. That's what happened. I think I didn't run probably some parts. Let's see. Yeah, I didn't run previous blog, so I have to go back, run everything, and just go back. As you see, there is no null on each column because two imputations and also dropping NA columns. Okay, we don't have that much of time, but I go skim through the working with the categorical columns and encoding. In the next class, again, I'll go back because I want to explain the details. But let me talk here. Okay, one of my variables is embarked. It has category of, I think, let me just check it again. SCQ. Oh. So there is, I cannot enter any non-numerical values into machine learning algorithm. I should convert it to a numerical equivalent. Mm-hmm. By how? There is two approaches. One is one-hot encoding. Another one, label encoding. So let's first talk about one-hot encoding. Basically, it's similar to probably to your previous experiments. I make a dummy variables for each category. So embarked underline S, embarked underline C, and embarked underline Q. So if the first passenger embarked in the port S, let me check it, what was again? So S was Southampton, Q Queenstown, and C Cherbourg. So let's just call them port C, Q, and S. So port, if somebody embarked in port S, this dummy variable would be 1, the 2 is 0. If embarked in port C, the first one would be 0, the next one 1, the last one 0. And same for Queenstown or port C, the first 2 is 0, and the last one is 1. Because embarked Q, embarked is Q. Embarked C, embarked C.
The way we do is, make them to S is transformed to 0, say transformed to 1, and Q transformed to. What's the difference between the two methods? I mean,
could you say your question again?
I mean, the way we use is dummy the variable, right?
Yes.
And we use transform S to the 0, the say to the 1, and Q to the 2.
So for each category of your categorical variable, you make a dummy variable. If that dummy variable is 0, means it's not that category. If it's 1, means it belongs to that category.
Oh, got it. I know.
You got it, point?
Yeah.
So for example, embark S is 1, means the category variable related to category S, but embark C is 0 because this category is not 0. Embark Q is 0 because in the first observation, the category is not Q.
I think that way it can, prevent the categories. If the value is 0, it can be it belongs to category S, and the value is 1, the category belongs to the C.
No. Just look at this observation. First observation. This is passenger, let's say ID 1. So this is category, that passenger embarked in the port S. So look at the embark S, it's 1, means it's embarked from that. But look at embarked underline C, it's 0, means it didn't embark from that port. Embark Q is 0, means the passenger hasn't embarked from that port. Same for passenger 2. The category C means it didn't embark in S, it embarked in C, and hasn't embarked in Q. If you have other questions, please ask me, because I need to go further. So if you still have questions, just reach me through office hours so I can go further for you. So this is one way. So you convert the categorical variable to associated dummy variables and delete the categorical one, because we already put its equivalent in as dummy variable. But let's say, what is label encoding? So as you might know, machine learning is much more flexible, so it doesn't have a statistical limitation. Just keep in mind first. Second, in label encoding, you associate a numerical value to each category. So let's say if it's P class, and the category are class 1, class 2, class 3. It is more intuitive to say equivalent for class 1 is number of 1, for class 2 is number of 2, and for class 3 is number of 3. It's already labeled 1, 2, 3, and also it makes sense because there's an order between different classes. So what we can do with P class, we just convert the string to the numerical value. So, but what about embarked? So between ports doesn't make sense. I mean, intuitively, you cannot say Queenstown is 1, Southampton maybe 2, or other numbers. But it's not the best way actually. But when you have limitation, you don't have any other options, and you want to do label encoding, because at the end you cannot import those categories to models. We just assign a number to each label. It's not the best way of doing that, but machine learning algorithm is much more flexible than a statistical algorithm, so you can do that in machine learning. But why we do that? So just assume instead of just 3 ports, I have much more than that. A, B, D, F, G, H. So 3, 6, 9 categories, or more than that. Maybe just go to some port in the Germany or Ireland. So in such a case, when you do hot encoding, you have too many variables. Later, we talk about importance of features or importance of variables. When you have too many variables, that variable lose its importance. So first, it was just one variable. Then we just divided to too many variables. So in that case, it's similar to losing that variable, because when you divide it to 9 variables, you divide this importance to 9 variables. So at the end, you don't have a better model. You don't have a good model. What can you do? Do label encoding. Just instead of making 9 variables, just make 1, but assign a number to each category. And you try. You go back and forth. You try one encoding, label encoding, see which one is better. Maybe if you assign a number to each of them, at the end it doesn't good. So, but we try. We just go back and forth, see what happens. The best way, however, when you have too many variables, too many categories, if you can merge them categories together, is the most efficient way. For example, let's say first 3 are England. So I put E. Next 3, maybe somewhere from Germany, and next 3, somewhere from Ireland. Now, if it's possible to merge them, just merge them. Don't make 9 dummy variables. Here, maybe based on location, you can say the first 3 are England, the second 3 Germany, the last 3 Ireland. So instead of 9 categories, now I have 3 categories. So with these 3, I can do hot encoding, one hot encoding actually. So I make 3 variables. This is very good. But at the end, we just try different encoding and see which one brings a better performance. One approach, when you have too many categories, you can just merge them if it makes sense. If it doesn't make sense, or you don't know how to merge them, don't merge them randomly. So this is very important. Don't merge randomly. It's a very bad thing. Don't do that. If it makes sense, for example, based on location, you can merge them. That's totally fine. So we don't have that much of time for now, but I just skimmed through the next codes. Because I tried one hot encoding and label encoding, and I want to look at the performance. Let's just summarize them. Oh. What time is, okay, I think. So let me just for today skim through them. So here I'm bringing functions, importing functions for doing a label and one hot encoding. You can read the explanation later. Then for each categorical variable, I did 2. I did indexing, which means equivalent to one label encoding, and also I did one hot encoder, which is for one hot encoding. Then I make a feature column because you know that when you want to run machine learning algorithm in PySpark, you merge all the independent variables into a feature column because it's Python PySpark friendly. Then I'm importing to classifier of logistic regression and random forest. I'm importing a pipeline. Later, I talk about pipeline further. Then I'm making 3 pipelines for logistic regression using one hot encoding, logistic regression label encoding, and also label encoding using random forest. Next step, I'm doing, I randomly split my data in the 80% train, 20% test, and I use random number seed of 110. When you split it happens randomly and it follows some random instructions, but every time I want to get exactly the same result, so I'm using a random seed of 110. You don't have to do that. So in that case, every time I get exactly the same results. Okay, then I'm fitting logistic regression. I mean, 2 different logistic regression using one hot encoding and label encoding. Okay, now I'm with dot transform method. I'm doing prediction for the train set and test set. Then I bring the evaluator for AUC using binary classification and multi-class classification for accuracy. Then I'm making object for accuracy and AUC, doing evaluation. Let's now look at the results. So we had 2 different encoding. We want to see which one is better. So look at AUC of logistic regression with encoding. Accuracy AUC of test set is 0.69. AUC of train set is 79. There is a huge gap between test and train in terms of AUC. Is an obvious sign of overfitting. So what happens when you do accuracy? So with one-hand encoding, the accuracy of test set is 70%, train set is 80%. Even accuracy, there's a big differences. Let's look at what happened in the label encoding. 74 and 78. The gap is much less. So we did label encoding even over the ports, but the performance looks actually better. Let's do for checking the accuracy. Yeah, even accuracy is better. I mean, the gap is much less. So you're more confident that you can generalize your model for new test set. This is another thing that sign or evidence for why I'm saying that the data mining project is a cyclic process. You might do label hot encoding, go to the end, and your model is not good. You go back, do label encoding, go further. So in the next class, I go to the details of encoding, and also I'm talking about feature selection, because feature selection is also a method for avoiding overfitting. On top of that, it doesn't guarantee, so you might do different encoding and feature selection, maybe your performance doesn't change that much. Again, you try and just select the best. So I already shared the Jupyter Notebook with you. So for the next class, you can even run the codes by yourself. But again, I go back from here and talk about encoding details of the code, because today I didn't have time to go to details. And we compare different approaches for avoiding overfitting in the next class. Any questions?
Yeah, I have a question about assignment.
Yeah. This assignment that I just talked today or previous assignment?
First,
Okay, so no, it's for teaching now. After the class, I look at your question, but for the today content. What about people over Zoom? Do you have questions?
When is the due date of the project proposal?
It's not proposal. You just define your topic, data set, and your group names by the end of this week. I give you another due date for proposal and writing your introduction later in November. Early November, you should do your proposal, introduction, and other parts. But for this part, which is almost nothing, you should give me your title, your data set, project title, your data set, and your group mates.
Okay, that's cool.
Okay.
Thank you.
Details of what?
About the group details.
I haven't made the assignment yet. I make it today. Okay, so what was your question now? Is there only now or can you
then on start. Just select these two and now you can create yeah, you just have two columns. Yes. Year and start point. You look at the max. You do for year and max. Oh, I expected. Let me go to my X and check. Send me your output. Okay. You just go to file. Just go to send to my data. To the notebook file.
Okay, that's for today, and have a good rest of the day. See you guys.